Thank you for joining us today. I'd like to welcome you to the LVH-900 system overview. My name is Dave Howden. I'm Technical Services Manager with the Loudspeaker Solutions Group based in Chester, Pennsylvania. So let us get started. So our L series is Biamp's newest community product category for large venues. It's a large-scale, high-performance, all-horn-loaded loudspeaker system designed to address the most challenging venue performance requirements, be they those that have SPL needs or pattern control needs for intelligibility. We hit most of the marks here. It's the industry's first triaxial beamforming venue horn. We have the ability to do variable vertical dispersion, extremely high output with point source systems that array together very well. We tick all the boxes: high output, dispersion control, low distortion, and smooth frequency response. The LVH-900, it's a large system. Physics says it needs to be to provide the sort of performance that we're going after here. These point source loudspeakers allow you as a designer to tailor the coverage of a single loudspeaker or an array of speakers to precisely cover any audience area with very smooth, even full range sound distribution. As with many of our products, they're designed for use indoors or outdoors, and with their high output capabilities and pattern control, we're able to address audiences from hundreds to tens of thousands of seats. It was designed really with high continuous SPL in mind, which is often a requirement in these spaces, as is excellent voice band clarity and minimal voice band coloration. And of course, low distortion is always important, especially at high output levels. The LVH-900 provides smooth, consistent horizontal and vertical coverage over its entire frequency range. The pattern control is maintained horizontally and vertically to below 400 Hertz for a single cabinet. Our beamforming provides the ability to combine two LVH-900 systems into a seamless acoustical array, and we're constantly developing new patterns for these systems. We've also made it very easy to design with LVH-900, as all the patterns are in a single unified GLL file as opposed to a bunch of separate files. That adds time to your design process when experimenting, or what might be the best product or the best version of a product for your application. So we can quickly and easily change array configurations in Ease Focus 3 should you choose that workflow prior to exporting the array configurations into Ease 4 for more in-depth analysis of the systems. As mentioned, we of course have indoor and outdoor models. Our indoor models are available in standard black and white finishes. Of course, we have matching rigging hardware and display brackets, and we could do custom colors for your indoor-outdoor systems also. Our outdoor or WR versions are available standard in gray, black, or white finishes, and they feature our extremely durable, weather-resistant polyglass enclosure construction technology. So target applications for the L series is primarily larger venues. We're talking your various types of stadia, indoor arenas, your medium to large auditoriums, or your large-scale worship spaces. Let's get into some of the system specifics here on the LVH-900. Cabinets, they're large, not a small cabinet, but to achieve good pattern control, we need it. The indoor version comes in at about 250 pounds. It has a powder-coated perforated steel grill backed with a transparent woven fabric. It's painted with a low-gloss, uniformly textured finish, and they are constructed out of high-density 15mm Baltic birch. Internally, since these are designed to be arrayed together, we have metal rigging frames inside. And the outdoor weather-resistant version, as the polyglass is a bit lighter, comes in quite a bit less in weight. The grills are marine-grade aluminum, again featuring a hydrophobically treated, acoustically transparent woven black fabric backing. Keeps the weather out. Keeps the bugs and critters out, which are certainly an enemy of outdoor systems. It's protected with a very uniform weather-rated finish over our 15mm thickness polyglass enclosure. And the systems are IP56 when used with the input cover plates and appropriate gland nut cable ingresses. They are a three-way design. They use 4 1.5-inch voice coil high-frequency drivers that feature neodymium motors and ketone polymer ring radiator design, very lightweight, excellent transient response, inherently weather resistant. We also use 3 of our 2-inch exit community M200 mid-range drivers, which we've been building and refining over the past 25, coming up on 30 years. Mylar diaphragms, very low distortion, very low compression ratio, high sensitivity, and produce excellent transient response, especially compared to cone type mid-range drivers. And low frequency drivers, there's 4 12s within the system, utilizing 3-inch voice coils and a cast aluminum chassis. One of the very special parts of this system, which really allows it to work, is our patent pending collinear manifold, which seamlessly integrates our mid and high frequency driver energy, and then projects that into our unified waveguide, which combines all of our drivers into one coherent wavefront with our DSP processing. So general large front of house speakers, require high output, of course, should be expected. Ideally, we have wide bandwidth pattern control, low distortion, smooth response. Traditionally, to get 1 and 2, the trade-off was 3 and 4. It's a balancing act. Got to follow the laws of physics. Larger transducers do allow higher output, but often at the cost of higher distortion or diminished response linearity due to component spacing. So we really paid attention, especially where we could in the mid and high section, to keeping the components close together, so that we can take advantage of all these benefits. So using smaller, high-efficiency components in an array form on a revolutionary manifold helps us maintain that high output capability. We're able to reduce the drive level to individual components, which helps us retain low distortion and smoothness of sound. We're able to produce a coherent wavefront with the driver spacing, as opposed to a system that may not be a triaxial type system. And we can do very precise beam shaping over a wider bandwidth due to the driver spacings also. An idea of the high output broadband capability of these systems, based on a pink noise signal. For the LVH-900, which is a 60-degree version, and if we chose a 40-degree vertical, we can achieve about 105 dB at 100 feet or 30 meters after processing. The general range of of max SPL outputs, and this is again continuous. We're not talking peaks here. We're talking continuous pink noise signal. Depending on the pattern that the vertical pattern that you choose for an active standard single box, 133 to 137 dB range, depending on the pattern chosen. For the Active Plus models, which is the dual cabinet systems, which we will get into much more detail on, we can achieve between 134 and 140 decibels broadband output. Again, pink noise signal, continuous, not peak numbers here. 60 to 18 kilohertz is the stated frequency operating range for these systems. They do have good low frequency response and as much HF response as you could ask for. Great horizontal and vertical pattern control, and we can electronically vary the vertical dispersion of the systems in order to provide the coverage for your audience areas. There are two fixed horizontal patterns of LVH-900. We can have a 60-degree horizontal or a 90-degree horizontal. Obviously, separate skews. And choose the pattern to meet the needs of your venue. Multiple drivers and amp channels give us the ability to beamform a wide range of vertical patterns for our single and dual cabinet configurations. We do this by varying the phase and amplitude relationship of the driver pairs with linear phase FIR filters. This is how we create the various vertical patterns, whether it's a single or a dual cabinet system. Unlike competing systems, that have fixed horn angles, we can and are continuing to develop new vertical patterns without physical waveguide changes or additional skews. So maximum flexibility there. All beamforming settings are available exclusively in our ALC or amplified loudspeaker controller preset library. So let's take a look at the AS systems. The patterns we currently have available are 60 degrees, 40 degree, and 20 degree vertical patterns in the 906 or 909 systems. Software configurable, we say 6 horn patterns plus because this is a constant evolution, but we get that with just 2 skews, keeping it simple. The AS models are easy to implement and distributed point source applications, and we'll take a look at some of those applications later on in the webinar here. The Active Plus systems. These systems are based on 2 cabinets that are treated as one. Currently, our dual cabinet system patterns are 100 degrees, 80 degrees, and 20 degree vertical patterns. Depending on the configuration of the array, we can have pattern control to below 200 hertz, again, depending on the length of it, and depending on the vertical pattern chosen, we can have up to 5 dB higher output than the single active standard models. Active Plus models are priced individually at time of ordering, but are only sold into pairs. And the Active Plus must be defined when ordering to ensure the proper input panels are configured into the systems. Splay brackets, of course, must also be ordered separately because we don't know which configuration you're going to choose, which DSP configuration. So those are a separate item at time of order also. So 12 plus pattern choices from only 4 SKUs, whether it's indoor, outdoor, giving you as a designer maximum flexibility through a very small number of SKUs. So let's get into some of the details, differences here. So the AS, priced and sold as individual cabinets, intended to operate as a single cabinet point source system. The suggested wiring requires 6 amplifier channels. The Active Plus system again, priced individually, sold in pairs, but they're internally identical to the active standard system. The only real physical difference is the input panels. The Active Plus systems, to achieve the wide range of beamforming, do require 7 mid-high amplifier channels, and we suggest 4 amplifier channels for the system. But again, we'll get into some more of those details. So we are able to match our Active Standard and Active Plus systems within arrays. Obviously, they're powered separately, but we could use top or bottom of the array. Perhaps we need a wider vertical coverage to cover a large raked seating area. Maybe we'll choose an 80-degree vertical for most of the seating, and perhaps a downfill as an Active Standard to fill under the array, or perhaps courtside seating, or just the lower seating in a large outdoor venue. The longer the array, of course, the more low frequency pattern control we can achieve. And we could get coverage like a line array, but with far fewer elements. And that can lead us to significant cost savings, especially when using our available indoor brackets. Our cabinets are not all burdened with touring hardware, as they are designed for permanent installation. So this could lead you to, possibly half the number of loudspeakers to rig and power and install compared to a line array system, which will certainly help you on the installation labor end with the time savings. All right, let's get really specific now. We're going to talk about the active standard systems in a bit more detail. Generally, you intend to be single distributed elements, or you could build them into an array, but we'll talk about them singularly for now. A configuration could, though, include perhaps a 60-degree horizontal top cabinet in a 2-element array, and a wider 90-degree element for the bottom of the array for your downfill. Each of the active standard models requires 2 ALC amplifiers. We specify our ALC 404D, our 4-channel amplifier, for the mid and high frequency drivers. And we suggest the ALC 1604D with bridge channel pairs for the low frequency sections. Again, there may be some flexibility on the low frequency side of the system to help save Biamp channel count depending on the particulars of your installation. So the LF section of an LVH-900 has 4 12-inch low frequency drivers, each rated 500 watts continuous power handling, but they're wired up in pairs inside. So we end up with 2 8-ohm 1,000-watt RMS loads to drive on the back panel, which is why we suggest the two channels low frequency amplifier. The mid-frequency section is comprised of 3 of our M200 2-inch exit mid drivers, which handle 50 watts RMS each. They are powered in the AS system as an outer pair, and then the middle one is addressed as a single. Easy to drive impedances. The high frequency section, again, 4 1-inch exit drivers, 35 watts power handling each. They are again powered in pairs, and each pair in the active standard model is an 8-ohm load. So the active standards use a single input panel per pattern. All 6 driver inputs are on a single panel. And as you can see in the left-hand picture, the second panel is blank, but we'll get to talking about the uses for that second panel position shortly. So single input panel, we use lever action terminals to make our electrical connections within these systems. They can accommodate conductors, whether it's wire or ferrules, up to 10 gauge wire size, or over 5 square millimeters in size. As a note, the outdoor cabinets also include an aluminum cover plate with holes in it for customer provided gland nuts for your wire ingress. Pictorially, to show you what I've been talking about, the number of amplifier channels, and this is how the beamforming works. Within these systems, we are varying the vertical pattern only in the mid and high frequency section within these systems. And as shown here, for an active standard system, your high frequency 1 and high frequency 4 get the same input signal, and high frequency 2 and 3 also. The same can be said for the mid-range drivers. Your mid-frequency 1, mid-frequency 3, same signal applied. Mid-frequency 2 has a different signal applied. And this is why we need our 4 amplifier channels from our ALC 404D in order to power the active standard systems. Here's a chart that I grabbed out of our installation guide. All the documentation is on Biamp's website for the LVH, but this gives you an idea of the typical wiring for an active standard element. We also have a neat optional panel which some of you find very useful. It's called our pass-through panel. This is only applicable to the active standard unit, and it provides us the ability to pass from one element to another the mid and high frequency signal. We would expect that this would be used with same pattern devices, as they will be both getting the same processed signal. The pass-through panel is one of the panels that can occupy the second position, and it allows us to, assuming you're addressing a common seating area, you can pass the mid-high amplifier level signal from one cabinet to the next. The second cabinet will typically still require its own low frequency amplification though. It's ordered as a separate SKU. It's field retrofitted by the installer, but we've made it incredibly easy. Again, the instructions, very simple guide, is available online. So 2 same pattern cabinets. So 2 60-degree cabinets, 2 90-degree cabinets. Could make for a more cost-efficient installation. Perhaps it's a central cluster in an auditorium or a similar type environment. Or perhaps we have systems covering a long linear same geometry seating area, such as in a sports venue. It enables us to parallel from one cabinet to the adjacent cabinet mid-high drivers. And this can also be very advantageous in mono systems for reducing your amplifier count and the amount of conduit and copper up in the air. It's a very complicated looking drawing until you kind of drill down into it. The upper left panel is our main input panel, driven by a single 404D for our mid-highs. And then internally, we jumper over to the pass-through panel in the second position, which then outputs our amp level signal to the adjacent cabinets mid-high input. And as described earlier, and I'm showing here, we prefer to use 2 separate low frequency amplifiers for these systems. Some of this judgment calls, sometimes you don't need every last decibel. You're really going for the quality and the pattern control of one of these systems in a shorter throw type configuration. So it is certainly possible to come up with other configurations on the low frequency side to make for an efficient installation. Active Plus systems. So the Active Plus systems, again, these are always dual cabinet systems, and our beamforming with these is achieved by powering our drivers in mirrored pairs. But instead of mirrored pairs within each cabinet, we actually address it as top and bottom cabinets, because we're really treating the system, and we've developed the beamform patterns to treat it, as a single element. Ideally, we use two ALC 404D system, ALC 404Ds for each system, and two 1604Ds for the low frequency section. The drivers, they don't change, just the quantity of drivers changes, and now obviously we're paralleling our mid-high drivers, which the ALC 404Ds have plenty of headroom to address them in parallel pairs. The input panel, you see changes on these systems. So we have dual input panels. The left panel provides the input for our high frequencies, which on a per cabinet basis are now driven as individual drivers. So one ALC 404 to drive the 4 HF drivers in the cabinet. And the mid-range also, we are individually addressing those drivers, number 1, 2, and 3. The second panel on the right-hand side, where we previously saw the pass-through panel, that is where we provide our low-frequency input to the systems. So we've just kind of expanded, how we are doing our beamforming here. We are still driving symmetrical pairs of drivers, except we've split it up between top cabinet and bottom cabinet as shown in the driver. So the same amplifier signal is driving the H1A on top and the H4B on the bottom, and that continues inward. Same for the mid-range. We drive our top in the top cabinet, bottom of the bottom cabinet mid-range driver, then the middle ones, and then the inside ones. It's a lot of cabling to provide this sort of support of flexibility. So generally, I think that you'll find that providing a junction box exterior to the system will be the easiest way to drive these systems. Some considerations that need to be made when planning for the installation, but this is how we're creating a pair of dual cabinets and creating a single beam formed pattern. The wiring on these, again, to provide this sort of flexibility, takes a fair amount of support, but this is also detailed inside the installation guide if you want to dig into it a little bit further. So differences between active standard and active plus systems. So the active standards, again, priced and sold as individual cabinets, intended to operate as a single cabinet point source driven by its own amplification, or perhaps using pass-through panels for adjacent cabinets. 6 amplifier channels is the suggested powering for the system. The active plus systems, priced individually, sold only in pairs, so that we can make sure we ship you the correct input panel configurations. 11 amplifier channels is the suggested number, and the splay bracket between the elements must be ordered separately based on your design work and ultimately which pattern you've chosen to use for your application. So reducing, I've talked about channel count and potential ways to reduce channel count, within the LVH systems. We've made it easy to drive the low frequency, which is obviously has the highest power capacity, and a bridge 1604D. We prefer that for the peak voltage headroom when possible. But the fact that some installations, amplifiers may be 100, 200, 300 feet away from the cabinets, and 8-ohm loads seem to be the best choice to go for each of those low frequency sections. That's not to say you couldn't perhaps use one of our 3202D amplifiers in a bridge mono configuration and drive a 4-ohm load. If the cable losses and math are on your side, it's a possible way to reduce your copper count and your amplifier expenditures. Again, these systems are capable of extremely high output. You decide, especially for indoor environments, do we need every last bit of SPL? Sometimes the answer is yes, especially in live performance venues, but perhaps not as much when you're dealing with a smaller auditorium type venue. But feel free to give us a call here in the applications group to discuss additional options for driving these. But we still have to separate our mids and highs the way that we previously stated, and for the beamforming to work, but we can possibly realize some cost savings on the low frequency sections. All right, let's talk about the rigging. Tried to make it as easy as possible to combine systems when you're doing more than one system, or using multiple active standards or active plus systems. We have 2 different rigging plates available, and each active plus system requires a very specific rigging plate and the angling to be correct. All this is shown and clearly called out in the EaseFocus GLL report when you produce that. Plates must be ordered separately for the Active Plus systems. If you're not using custom rigging, which is of course an option within our systems, the installer must install the correct splay bracket matching the ALC settings in order to properly produce the beamformed pattern that you have chosen for your application. And the splay plates are rated for indoor and outdoor use. A couple of examples here. If we were choosing an 80-degree vertical Active Plus system, we would use a Type 1 splay plate with a smaller end facing forward. If we're using the 100-degree vertical pattern configuration of an Active Plus system, that plate would essentially be flipped around. Again, this is all detailed to great extent within the installation guide. Our SP2 plate is the plate that we use when we're doing what we call our long throw configuration. It's the 20-degree vertical pattern that can be produced with the 90-degree or the 60-degree horizontal system. It's a much larger plate. You see that the faces of the cabinets are very close to being planar. It's actually about a 10-degree splay in between them. The splay plates are a high strength marine grade aluminum. As I said, they're just fine for outdoors. Our splay plates will support a maximum of 3 LVH cabinets in your array configuration. Beyond 3 cabinets, we'll need to start considering custom rigging. We also offer an array frame. It's designed, again, to support up to 3 LVH indoor cabinets. It can be suspended by the optional PY1, which does need to be ordered as a separate piece, or the array frame can be supported by the included eye bolts with the system. We give you a pair of them. And again, rated to support a maximum of 3 LVH-900 systems. And the array frame, please note this, remember this, it's not designed for outdoor use. If we need an outdoor array frame, suggest contact our friends at Polar Focus for that. We also have a pullback bar, which can be attached to the bottom cabinet only within an array. This can provide, whether it's additional lift point, or depending on the height of the array and the down angle, the center of gravity of an array just might dictate that you need an additional pullback. Again, this bar is not designed for outdoor use. It's likely, that for 3 deep arrays, just that we will need to use a pullback bar in order to get the proper downward angle, just because of where the center of gravity of a large array like this ends up landing. Anytime you're taking the LVH-900 weather-resistant cabinets outdoors, you really want to make sure that you have the proper rigging designed by a person or a company who's highly experienced in this area and understands the dynamic loads that can be presented in an outdoor environment. So please take heed of that. We also have, for indoor use, a U-bracket. This system is just a simple U-bracket. It'll hold one active standard cabinet. There's 2 different mounting positions on the arms to accommodate either a low profile mount, assuming the pattern lands where you need it to based on the elevation of the speaker. Keep it relatively tight to the ceiling, low profile, or you can have a lot more flexibility with it by using the lower position and get full rotation of the cabinet through the yoke. All rigging and brackets are available in black or white, gray for the outdoor side plates. And we can custom color these also. Supply us an RAL number, and we're happy to quote on custom color systems to meet the architect's needs. I mentioned Polar Focus before. They're the ones that are manufacturing our rigging hardware for indoor use. They're our preferred vendor for outdoor cabinet rigging. They have all the dimensions and understand the cabinets in great detail mechanically, and of course can provide any sort of custom rigging solution you can dream up. They also provide a wide range of mounting choices shown pictorially there. Take a look at their website, but these will attach directly to the flybar, the rigging frame on the LVH systems to make your installation that much easier. A couple more notes on the outdoor weather rated systems. They're 100% polyglass enclosure. All the systems use marine grade aluminum grills, 5000 series aluminum, for those of you into the details. We have our woven mesh cloth backing on these systems, which is more robust than the indoor system. It's of course UV resistant. Keep the weather out, keep the bugs out. We use all 316 stainless steel fasteners. Again, everything's identical on the outdoor models, rigging points wise, as the indoor models as far as the locations. And the system is weather resistant and been tested to all these different IEC standards. Right. One of the most asked for things is we are expecting to certify the system for EN 5424 middle of this year also, for systems that require that certification. The outdoor systems have it's the same standard input cups to get your cable ingresses into. We include aluminum cover plates to go over those input cups. The customer supplies the gland nuts or the conduit fittings. There's a lot of different sizes of multi-conductor cable out there, and we decided not to guess which one you might choose to use. So we don't include those with the input panels, but very standard holes are punched in them. Again, you can take a look at more details in the online installation guide about that. We include hole plugs to cover up the unused holes over each position. And we also, on the outdoor cabinets, include bolt cover plates to keep water from pooling. There's 4 points, two on the top, 2 on the bottom, that actually attach the face to the back of the cabinet. Think of the rear of it as a shell that goes over the engine block, if you will. We didn't want water pooling in those plates, so those are included on the outdoor systems, also just to aid in more weather resistance. As I mentioned, the EASE GLL data, which is available for download. All patterns are in a single GLL data file. The array frame and the splay plates are integrated into the GLL. The pullback bar is not. There's too many dynamic loads at work there to ask an acoustics program to deal with. It's compatible with Focus 3 and EASE 4. As previously mentioned, with all of the different patterns and options being available within a single GLL, makes for a very time-efficient process evaluating which pattern is correct without necessarily adding another speaker to your project or selecting it simple through the drop-down menu. We can pick our different configurations for standard or plus arrays. And for those of you that want to delve further into it, well, you may start in Focus 3 to define your arrays, build up a typical audience area, or perhaps the whole venue, depending on the size of it. You can, of course, export the array configuration out of EASE Focus 3 and import it into EASE Focus 4 while retaining any splay plates and angles and obviously the pattern information. If you want to do more in-depth acoustical analysis of a project. The EASE Focus report also conveniently for smaller projects, contains all the array details. Of course, our aiming, our cabinet type, our splay between them, which array frame was used, splay plates. The only thing not included is the pullback, should that be required for your project. The GLL structure, you could select the number of cabinets when you bring the GLL into the EASE programs. I think it defaults to 3 when you first bring it in, but you can select the number of cabinets and then select the pattern of each of those cabinets through the drop-down list. Standard hardware mode will have the limitations of our standard off-the-shelf hardware. Should you decide to get more creative or need to build larger arrays, you can go into custom hardware mode and build away until the needs of your space are met. Either way, the array can easily be exported to EASE 4 for you to do further evaluations on. So, easy to use, available for download for a couple of weeks now. Feel free to give it a shot. LVH-900 is the styling of our LVH-900 is really inspired by our I series. The LVH-900 may be the anchor, the main PA, for the system, but often you might need fill speakers or subwoofers or speakers for other areas of the venue that are perhaps shadowed and just not reachable due to geometry of spaces. They match up very nicely and very well sonically. The subwoofer we suggest for integration at this time with the LVH-900 is our IS-8218 subwoofer system. Works extremely well, very high output. That's probably the number one question at this point, which subwoofer to use with the LVH-900. So consider the IS-8 218 system. Let's take a look at a couple of application examples. These are just examples to get the thought process rolling over what sorts of applications might I consider using LVH in, budget permitting, of course. Perhaps we use it in an auditorium. Again, we need to qualify our spaces acoustically and make sure that the pattern control provided by any system will give us the intelligibility we need. But I'm showing here an LCR system for an auditorium. Have about a 8 meter, 28 foot height mount. It's about a 30 meter throw, 24 meter width, or 80 feet, if you will, able to project energy into the space, no problem, into this slope seating area. And we are able to achieve, this is a broadband mapping, A-weighted, ±3 for most of the space, a favorable mounting height and projection distances and the slope of the floor help this work out quite nicely in an LCR type configuration. Might consider a larger type venue, perhaps an outdoor amphitheater. This particular space, I've modeled in a couple of active plus systems, left and right, configured as 20-degree vertical. And I've used a single center fill, in this example, an active standard 60-degree vertical system. The distance between the arrays is almost 100 feet, so it's a relatively large outdoor venue. But we're able to, with the beamform presets, create a very compact vertical energy beam in the mid-high band, and of course stacking two elements together is aiding our low frequency pattern control also within this venue. Taking a quick look again, just showing the LVH cabinets. There would probably be front fill, stage fill, subwoofers, and all those other expected items for a venue of this size. But again, we're able to broadband A-weighted achieve very even coverage, front to back, even with 140 plus foot throw, or 43 meters, if you will. And we don't have to get into using delay towers or delays from the sides potentially. Again, just to get the thoughts working for the sorts of applications, this would be on the larger end of the outdoor applications that we might consider this for a medium-sized venue. Moving indoors, perhaps you do a sports arena. This one happens to be set up as a hockey. You could obviously do basketball. Take your pick of sports in these sorts of venues. I call this a medium-sized one. It's probably 7,000, 8,000 seat single seating plane sort of space. Relatively low pick height, about 15 meters. Projection distances are fairly short. The spacing between the arrays for this particular application was about 40 feet, and I opted to show the LVH-900 Active Plus system in an 80-degree vertical configuration. Taking a look at the side view, the coverage of the space. Again, a wide variety of venues this could be, whether a university or college. And obviously this could scale up also to a 15, 20, 25,000 seat style arena also, where the LVH might be applicable. Able to achieve even coverage over 90% of the space, ±3 dB direct SPL within the space. The beamforming is certainly working for us, working well for us. Looking at even larger, let's consider a soccer stadium. We have our LVH systems. I believe these were the 909 systems, spaced out linearly across the overhang. You'll see the shorter lines. Those are under balcony systems for shadowed areas. But the main arrays are three elements deep. If I recall correctly, we used an 80-degree vertical pattern to address the lower part of the seating section in an active plus configuration, and a 20-degree element in active standard mode to address the upper seating area. And SPL mapping. This one is a broadband mapping, indicating the high SPL capability, which the LVH has no problem achieving in these environments. Again, if you need to achieve, your 105 dB, at 30 meters or 100 feet, LVH system will get the job done for you. So a bit of a quick wrap up here. LVH-900 series, it's the industry's first beamforming venue horn. We don't know of any competitors doing it on this scale. It's a highly scalable system to address a wide range of performance needs, but with a minimal number of SKUs, just 4 base SKUs between the 60 degree and 90 degree indoor, outdoor. I say 12 plus patterns because we have ongoing development of additional patterns for these systems. Point source system, extremely well behaved based on all the information. Our collinear manifold with all the technology in that, and our triaxial design. You can expect excellent intelligibility results out of the system. You're not going to have the speaker getting in the way of achieving great STIPA scores. Wonderful evenness in the spaces, and designed to easily array. With a 20-degree draft on each side of the cabinet, they array much more easily and look much more clean, much cleaner to the eye than competitive systems. And of course, you have our unbeatable outdoor durability, inside and out. We know how to do weather resistant, and we applied all of our knowledge yet again to the LVH-900 series. And of course, extremely high output capability with the system to address your needs. We have the highest output among direct competitors. There's not that many cabinets that even come close to LVH, but the examples shown, we do extremely well. We tick pretty much all of the boxes for high output, dispersion control, low distortion, smooth frequency response, and additionally, our ease of arrayability with standard hardware, our evolving catalog of horn patterns, and a low number of SKUs to keep track of with these systems. And we're looking forward to, hopefully, if all goes well, into the third or fourth quarter of this year, getting out there on the road with some select cities in North America initially, to allow you to hear these systems, because hearing is certainly believing, and it takes a little bit of an effort to set up and demo systems like this, but we look forward to bringing them to a city near you soon, hopefully. And with that, it's a lot of information in a fairly short amount of time. I want to thank you for your attention. We're very excited here at Biamp about the LVH series and the possibilities for this system. If you have any deeper technical questions, feel free to contact me directly. My email's on there, or you can reach us through the normal support channels at Biamp via email or phone. Thanks again. Have a wonderful day.